Hello friends, now we'll discuss one more problem related to the shift and add multiplier. So already in last video we have explained about the flowchart and the procedures for the shift and add multiplier. Similar procedure to be followed for this multiplication also. Now we'll take the example 2 with the multiplication of 13 into 11. So 13 into 11, so the 13 is your multiplicand and 11 is your multiplier. So 13 we are storing 1101, that is it is a multiplicand. So multiplicand will be stored in the register B. So we have B. B will be used to store the multiplicand as 1101, and we have Q. Q register is used to store the multiplier. What is your multiplier? I have the multiplier as 1011. So 1011 is your multiplier, and A register holds 0 as like we have explained already. A is the accumulator register, is used to store the value of initial value as 0. This is your initialization purpose. So we have B register, it is a multiplicand, and Q register is a multiplier, and A register, it is accumulator register, it is initialized to 0, and N is the number of bits. What is N now? What is N is equal to 4, because number of bits we have is 4 bits. So what will be our resultant? N into N, we will get the resultant of 2N bits. Right. So now we'll start the process, initialization process. This is initial step. Right. And then what we have to do after initialization, we have to check the value of Q0, whether Q0 is equal to 1. Yes, Q0 is equal to 1. So when Q0 is equal to 1, then what we have to do? We have to do the process of A produces A plus B. What is A? A is the accumulator register. We'll have the resultant of 000. And B is the multiplicand, will have 1101. So we have to do the process of A produces A plus B. So 0 is added with the multiplicand and we will get the resultant of 1101. And Q as such we will store. Right? After performing A produces A plus B, and then we have to do the shift right operation. So what you have to do? Shift right of A and Q. Shift right of A and Q. After doing the shift right process, it means that MSB bit will be 0. This one will come here, this one, and this 0 will be, and this one will be shift right operation. So 1, 1, 0, 1. We will get the resultant of 1, 1, 0, 1. Right? So it is initialization 1 and then step 1. Right? We are done with the shift right. After performing the shift right, the N is reduced to 1. So initially N is equal to 4. Now N is reduced to 3. And checking with the condition that N is equal to 0. If N is equal to 0, then we have to stop the process. Otherwise, again we have to repeat the same process. So we are coming to and we are checking with the same process with the Q0. What is Q0? For us, what is Q0? Q0 is equal to 1 again. Right? So if it is 1, what we have to do? Yes, we have to do A produces A plus B. What is A produces A plus B? A produces A plus B. What is A? 0, 1, 1, 0. And what is B? 1, 1, 0, 1. So if it is that the case, then when we are adding that, we will get the resultant of, what is the resultant we will get here? 0, 1, 1, 0 is added with 1, 1, 0, 1. What will the resultant? 1, 1, 0, and we have 1 and 0. This one will be discarded. So we will get the resultant of 0, 0, 1, 1. And Q registers will be 1, 0, 1, 1, 0, 1. That is remains same. After performing A produces A plus B, we have to do the shift right operation of A and Q. Shift right operation of A and Q. When we are performing shift right operation, again, when we are performing shift right operation, what is the result we will get? We have a carry bit, isn't it? We have a carry bit 1, because already we have a carry bit, it is remains same, no? 1, 0, 0, 1. Right? And then here 111, 0. We will get the resultant of 1001 and we have 1110 after performing the shift right. So this is your step 2 and the count is decremented to 2. Again I am checking with the n value. N is equal to 0. No, n is equal to 2. Then we have to repeat the process. What is the process? Again we have to check with the Q0 bit. What is Q0 bit? Q0 bit is 0. If it is 0, then we have to perform only shift operation. We have to perform only shift operation. Shift right of A and Q. So what is shift right? We will get 0. What we will get? 0, 1, 0, 0. This 1 will be shifted here. You will get 1, 1, 1 and 4 ones. So what is your count? Count will be decremented to 1. This is your step 3. Again checking with the condition that what is Q0. What is Q0 for us? Q0 is again 1. What we have to do? Again we have to repeat the process that A produces A plus B. If Q0 is equal to 1, we have to perform the operation A produces A plus B. This operation to be performed again. So what is Q0? It is 1. So what we have to do? A, what we have A registered, we have 0, 1, 0, 0 and multiplicand is 1, 1, 0, 1. When we are adding it 1, 0, 0, 1 and remaining, and we have a carry here. So what you will get? 0, 0, 0, 1 and 1, 1, 1, 1. So it is this process of A produces A plus B. After performing A produces A plus B, we have to perform shift right operation. So we have a carry over here. So we'll have a carry. This is your carry bit 1, 0, 0, 0. And again here we have 111. This one will be shifted here 1, 1, 1, 1. This is your shift right of A and Q. The count is equal to 0 and this is your 4th bit, and we can stop the process here. So when you are multiplying 13 into 11, we will get the resultant of 2n bits as 1, 0, 0, 0 and 4 ones. So this is your product. Thank you friends.